Okay, so we're going to pick up where we left off with regards to our conversation of multiplying numbers that are a combination of positive and negative. So we should be able to quickly tell without actually doing the work, without actually doing the calculation of whether an expression made up of multiplication and or division is going to give us a positive or a negative outcome. So remember what we talked about in class today, that we simply have to add up the negative signs. So I've got 1, 2, 3, 4. Okay, so the number of negatives, and I'm just going to put in parentheses, the number of negatives, that's equal to 4. 4 is what type of number? 4 is even. So what did we say about an even amount of negatives being multiplied or divided? We said that that will give us a positive result. If we look at the next example, just one more for practice, we add up the negative signs, 1, 2, 3. Again, you don't need to do this normally, but we're going to make a record of it on the notes just for clarification. So the number of negatives, this time it equals 3. 3 is what type of number? 3 is an odd number. So that means we're going to get, whoops, I don't want to make that mistake. That means we're going to get a negative result, Okay, because we know it boils down to an even amount of negatives being positive or an odd amount of negatives being negative. So that's a quick review. But now let's expand the discussion into exponents. So I want to make sure I understand what this exponent right there means. It says to multiply three negative twos. Multiply three negative twos. Okay, so it's saying take this base and multiply 3 of them together. So what's that going to look like? If I were to write it out as repeated multiplication, it would be negative 2 times another negative 2 times another negative 2. Now notice I'm using parentheses as multiplication. We should be familiar with that being one of our forms of multiplying. I could use a multiply symbol. I could use a dot, or I could use the parentheses. I like the parentheses in this case. So negative 2 times negative 2 times negative 2. I have a whole bunch of multiplying going on, and the numbers are, in this case, negative. I want to add up the negatives. I have 1. I'm going to put a different color check mark. I have 1, 2, 3. So number of negatives is 3. 3 is odd. So I get a negative result. And again, I'm not asking you to calculate. I'm just asking you to determine if we get a positive or negative result. We want to see if there's a trend here. So moving on to negative 2 to the 6th, we're going to have this base number, negative 2. And how many of them are we going to multiply together? We're going to multiply 6 of them together. So there's 1, 2, 3, 4, 5, 6. If I were to add up my negative signs to determine the outcome, well, it's pretty obvious. I have 1, 2, 3, 4, 5, 6 negatives, and that's an even amount. So I am going to get a positive. I'm going to get a positive result in that case. I'm going to get a positive result in that case. Okay, let's do another one. And I'm going to just do the base of negative 3. There's my base. I need to do 4 of those. So there's 1 that I've written, 2, 3, and 1 more, 4. Now let's count up the negatives since we're multiplying. 1, 2, 3, 4. 4 is an even number. An even amount of negatives we discovered from our rule is a positive result. So at this point, I wonder if you're beginning to see a pattern that's emerging so that we don't even need to do this repeated multiplying written out. Take a close look at the exponent. When we had a 3, I got a negative result, and 3 was an odd amount of negatives being multiplied. When I had an exponent of 6, well, I know if I counted up those 6, that would be an even amount, and that will give me a positive outcome. And when I did it one more time, when I had 4 negative 3's to multiply because of the exponent of 4, that's even, that gave me positive. So is it possible that we're beginning to see that we might be able to do this analysis of a positive or a negative outcome without writing? Well, let's see. Let's look at the exponent. 2 as an exponent is what type of number? Even. If I were to write out the amount of negative 3's being multiplied, it would be an even amount. So that tells me it's going to be a positive outcome. Without writing out the repeated multiplying, I see that my exponent of negative 5, is an odd amount. So when if I were to write that out, I'd have an odd number of negatives. So that would tell me I have a negative outcome. And if I did negative 2 to the 4th power, I would be writing an even amount of those, 4 of them all together. And if I count up the negatives, I would get a positive result. So when it comes to keeping track of the negative signs with exponents, this is really important, with exponents, then we can just look at the value of the exponent. So what rule can we establish for negative numbers raised to a power? Negative numbers meaning the negative base raised to a positive power. I'm sorry, raised to a power. We can say when a negative number is raised to a power. And what I mean is an exponent. There's going to be 2 statements we can make. If the exponent is even, like a 2 or a 4, then the result is positive. So we just simply look at the exponent. When we have a negative base, a negative number being raised to a power, we look at the exponent. If it's even, it will be repeatedly multiplied an even number of times, and the result will be positive. And the alternate to that is if the exponent is odd, for example, like negative 2 to the 5th, 5 is odd, then the result is negative. The result is negative. So there you have it. We established a rule in class with counting up the negative signs to determine positive versus negative. And now we can expand that to a quick discussion of exponents.